Hello students, welcome to NeoTeach. This is Srinivas Brahmoji. Today I am going to discuss regarding bitwise operators and followed by that special operators in this lesson. Okay, so let's discuss regarding that, right? So bitwise operators, as name suggested, bitwise. What do you mean by bit? So bit in the sense like binary bits. Bitwise operators are especially used to perform binary operations on individual bits of binary digits. So we will list out them first of all. Okay. So now following are the bitwise operators. There we will list as usual like operator and followed by that its meaning and followed by that one example for that. Okay. So first one is AND. We call this as a bitwise AND operation. Okay, so we will give one example like A and B, right? Next OR, bitwise OR operation and bitwise NOT operation and followed by that left shift operation means bitwise left shift, and so we are just taking example A, left shift 2, and now right shift operator, bitwise right shift operation like A right shift 2 we are giving here, and followed by that cap symbol. This is for bitwise exclusive OR. So XR also we can call XR. So bitwise exclusive OR or bitwise XR. Now, so in detail one by one we will discuss. So before discussing that, see here one AND symbol given to bitwise operator, but previously we used like ampersand two times, that is for logical AND. In the same way here we are using like pipe symbol, one pipe symbol we are using, this is for OR, two times we are using for logical OR, one time for bitwise OR, like that. These are the variation. So we will discuss in detail all these. Let's discuss one by one. Okay, so now in this we will discuss regarding how we can perform that bitwise AND and bitwise OR and exclusive OR and NOT operation, means bitwise NOT operation. So for this we will take one example, A is equals to 10 and B is equals to 11. So first we will convert this. How? Like see, this 10 we are going to convert it into binary, right? So divided by 2. 2 5s are 10. So the remainder we can write 0. Next 2 2s are 4. So the remainder we can write like 1. Next 2 1s are 2. Then the remainder is 0. And 2 zeros are 0, the remainder is 1. So bottom to up approach. So like this we will write like A value is equals to, in the binary number system we write like 1010. In the same way that A is equals to 11 we will take the value like that is 1011. And now let's perform bitwise AND bitwise OR and exclusive OR also we will perform. See, first we will take bitwise AND operation. Okay, so before discussing this bitwise AND operation I will explain one thing here. Simply we will take the statements like see, take P and Q or the statements. Now we will take P or Q and P and Q in mathematics like this. Okay, so for this like we will take some truth values for this. Truth values I want to take here. So what are the truth values I will take here? Like all the combinations like true, true and false, false. And here true, false, true, false. Like this, both are true. First one true, second false. First false, second true, and both are false. So here OR in the sense the priority goes to true, means both of them any one is true will get true. So like true or true will get true, and true or false will get true only, because true is the priority. Both of them any one is true, then we will get true in OR. So false or true will get true, false or false we get false. Means in OR operation both are false, then only we will get false. In another cases we are getting true only, right? In AND operation, what it is here? False priority. So both of them, any one is false, we are getting the false. See here, both are true, so that's what true. And true and false, we will get false only. And false and true also we will get the false only, and false and false also we will get the false. Means both are true, then only true. In another cases we are getting false. Okay, so like this, and negation also we will take. See here, I will write negation P. What this negation P? Not P here. Like if it is true, we will get the false. See, P value is true, then false. P value is false, then we will get true. Complete oppose. If it is true, we will get false. If it is false, we will get true. Okay, so now as per mathematics we are considering true false in the statements. Okay, that's fine. But now in the logical or technical we consider like true is nothing but 1 and false is nothing but 0. Okay, by this example here we will consider, see here, in the first one 0 is there, 0 and 1. So we are going to perform AND operation. Okay, 0 means false, 1 means true. So means false and true. In AND operation, any one is false, we will get false. So that's what, see, AND operation we will do here. 0 and 1 will get 0 because false only. False and true will get false. Next, 1 and 1 will get 1. Okay, and 0 and 0 will get 0. 1 and 1 means true and true will get true, means 1. Okay, like this 1 0 1 0, its equivalent value is 10 in decimal number system, right? Now the next one, bitwise OR we will do. Okay, A bitwise OR B, right? In the OR operation, so what is the thing? Any one is true will get true, because we seen in the table, right? So now 0 or 1 will get 1. Okay, 1 or 1 means true or true will get 1. 0 or 0 will get 0, because false and false are false will get false only, and 1 or 1 means true or true will get 1. Okay, 1 0 1 1, the equivalent value in decimal is 11. Okay, so like this we can perform bitwise AND and bitwise OR. Okay, now let's move on to exclusive OR, bitwise XOR or exclusive OR. So for this, see, A exclusive OR B we are going to do. One simple logic you remember here, in the exclusive OR both are different, means see here, here it is like false and true, both are different. Both are different in the sense one is true, one is false, both are different. In that case we will get true. In another case, means if both the values are same, either true or false false, in that case we are getting false only. So like that we will write, see, first one false true, both are different is there, that's what we will write, true, right? 1, true indicates 1. Now 1 exclusive OR 1, that means both are same values, that's what false, 0. Next 0 exclusive OR 0, that means both are same, so that's what false. Okay, 1 exclusive OR 1, both are same, that's what false. Like this we are getting in decimal value is 1. We know that decimal conversion. Okay, like this bitwise AND, bitwise OR, bitwise exclusive OR we did. Okay, and next bitwise NOT operation we will do. So for this we will take the logical circle. I want to draw one logical circle here for the bitwise NOT or complement operation. See, in this circle I will take some number lines. Okay, first line number this, and another line, and next line also I want to take, and one more line also I want to take, right? So here I will represent the values from 0 to some positive and some negative values I will do. So 0 plus 1 plus 2 dash dash dash. Okay, and 0 opposite minus 1, 0 opposite minus 1, and minus 2 continuation, minus 3, and so on, like infinite, like positive infinite and negative infinite, like you just assume logical circle. Okay, so now in the example I want to take one A value equals to 2. Okay, now I want to find the bitwise NOT or complement of A. That value is minus 3. See what I taken? I am taking here 2. Okay, the 2 opposite value is what? Minus 3. Right. In the same way, if you take some A value is like minus 999. Okay, then the complement of A is equals to 998, because the 998 opposite value is minus 999. So like that. So we will take one example. Directly we can say the answer in case of like interviews or in case of some competitive exams. We can in case of some written test, so we can directly answer such a logical questions by this knowledge. Okay, now the remaining two are bitwise left shift and bitwise right shift. So first we will discuss regarding bitwise left shift. Okay, left shift operation moves like shift the bits towards left side. So see one example, we will take the same example, A value 10 and that A left shift 2. Okay, A left shift 2 means I wanted to do 2 positions shifting towards left side. Okay, for this purpose this 10 I want to convert it into the binary like 1010. We know already in the previous session. Like see, now I want to form this completely into the byte. Byte means 8 bits combination, but what we have here only 4 bits we have, right? So that's what we will write this 4 bits right side, then the left side 4 bits we will write with only zeros. Left side 0 in the sense nothing value will be varying. Okay, so that's what we are forming byte. So 8 bits combination did. Okay, I will take one empty byte because I want to process this operation. It is very easy. So that's what extra I want to take one more byte, means 8 bits combination I want to draw here. And then after, now my thing is what? I wanted to do left shift of this 10, okay, 1010 in the binary. So whenever we want to perform the left shift, we should start from the right side. Remember, whenever you want to perform left shift operation, then you start doing shifting from the right side. So for that 0 you can move it into a left side. See, because 1 and 2, right, 2 positions I am shifting, moving towards left side 2 positions, that is called as left shift. How much we specified, that much. See here 2 is given, so that's what 2 positions we are shifting. Okay, so that's the 0 move into that, and in the same way 1 is moved to continuous cells, like see 0 move to here and 1 also move to there, and 0 followed by that, and next 0 also there. Right. After that we will get a question like, sir, what about this remaining, the left na? What about this? If they are 1 or 0, simply ignore it. You don't write anywhere. So what about this empty cells are here? That empty cells are there. What about this? So just you fill with 0. So if you have ones in this extra place also, you don't bring them. So just directly you can write zeros in this rest of the cells. Right. Now, so shifting towards left side is completed. Now what is the task? We are going to convert this binary into the decimal. For that purpose, we will take the bases of binary numbers. There are 2, we know that. Okay, all the bases we taken. Now the powers we will take from the decimal digits, like see 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. Okay, now so we should add all these. How we should add? See, first of all we have to calculate. See, 2 power 0 into this bit, so 0 into something we will get 0, and here 2 power into 1, 2 power 1 means only 2, right? Fine. So now this is completely 2 power 1 into 0, right? 0 only. Now 2 power 2 means 4. 4 into 0 will get 0 only. 2 power 3 means 8. 8 into 1, 8 we will get. And 2 power 4 like 16 into 0 will get 0. And 2 power 5, 2 itself 5 times, 32 into 1, so we will get 32. Now 64 into 0, because 2 power 6, 2 itself 6 times, 64. And 128 we will get, 2 itself multiply 7 times, like 0. But anyhow, we don't consider this 0 bits, because 0 into something we will get 0 only. So that's what we should calculate, this one and this one, these two. So both, see how we will. Like 0 into something will get 0, and 0 into something, 0 into something. 2 power 3 into 1, 8, we get the 8, and this is also 0 into something, and here 2 power 5 into 1 will get 32, and next one 0 into something, 0 into something. That's over. Now we should add all these values together. See how much 32 plus 8 means 40. So we take in a value 10, right? We did a left shift to operation, right? So now what we got, the result we got finally 40. Okay, finally we got 40. So this is the one example. Now we will move on to bitwise right shift operation. So bitwise right shift operation. Here also we take the same example, that A is equals to 10 and its binary equivalent also 1010, we know that. And now we are going to shift towards right side, A right shift to 2. Okay, so A equals to 10, that value 1010, we know that. Now we are going to take one byte in the same like in the previous example. So 8 bits combination we are taking. Okay, 8 bits combination. Now 1010 we should write like right side, 1010. The left 4 bits you fill with the zeros, because left side 0 in the sense nothing change the value, it's 1010 only, right? Now empty byte I am taking to process. Now I am going to perform the right shift, remember. So in the left shift what we did, so we started from the right side, because we are moving towards left side, that's what started with the right side. Now what we are going to do, we are moving towards right side, so that's what we are going to start with the left side. Okay, so we are moving towards right side means we are going to start from left side. So do this 0, you just shift it into that one, because see here right shift to 2 means 2 cells need to be shipped, each and every bit move to right side, 2 shifts, like 0 come to there and 0 will come to here, one more 0 come here, another 0 come to here. Now 1 will goes to there and rest of the 0 will come to here. Okay, now so what about this, sir? 1 left and 0 left, just simply ignore them, So what about these empty cells, sir? The empty cells you can fill with the zeros only. Okay, so now the shifting operation done. So what the next? Now we are going to convert it into binary to decimal, right? So binary to decimal means we should take all the binary base like 2 2 2 2 for every bit, and now we should take the powers like decimal powers 0 1 2 3 4 5 6 like this. Now so we should add together now. So as I explained in the previous example, here we should consider only the bit which having 1, because rest of the bits are 0 into something will get 0 only, right? 2 power 1 into 1 will get 1. Rest of the all things are 0 into something, right? So see here 0 into something complete 0, 0 into something, 0 into something 0, 0 into something, 0 into something 0, 0 into something 0, 1 into 2 power 1 means 1, 0 into something 0. Finally all together means add all together, we will get the answer 2, right? So here just simply you examine here what we taken, a value we taken 10, right? What we did here, we did a right shift operation 2, right? What the answer we got? The answer we got 2. So means the 10 became 2 here. Okay, so like this we will perform. So this is the example for a right shift operation, right? Now we are going to write one program based on this bitwise operators, right? So for this purpose, let's move on to Dev C++. Okay, here go to file and click on the new source file, and we can write a program to demonstrate bitwise operators. Okay, so now the link section hash include stdio.h. okay, so after completion this link section, we are going to write main function int main. In the main function, I want to take two variables like a comma b values. Done. A comma b values, right? After taking integer a comma b, I want to input those two values. So for that, I want to generate one output statement, that is like enter a comma b values. Like this I want to generate output statement by using the printf function, right? Now scanf function, inside the scanf function I want to write %d for the first value, %d for the second value, the first value ampersand a and the second value ampersand b. Like this I want to write. Okay, so now inside the printf function we will perform these operations. What that? Bitwise AND operation, bitwise AND. Okay, bitwise AND is equals to %d, bitwise AND equals to %d. So what that value? That value is a and b. I want to perform this operation inside the output function printf. Okay, now one more printf function for bitwise OR operation, that is equals to %d \n here a or b. Okay, a or b, OR operation we are doing. And now another printf function for bitwise XOR or exclusive OR, that is equals to %d new line. So that value also a exclusive or b value. Next one more printf function. Here I want to perform bitwise not operation. Bitwise not is equals to %d and new line. Then here not, what is not a? So not a, and then after one more printf bitwise left shift. Bitwise left shift is equals to %d. After that next line, and here a left shift to 2. As I explained in the example, the same thing I want to perform here. So printf function here same bitwise right shift. Right shift is equals to %d new line, that value is a right shift 2. Okay, so done. So I'll complete this program done. Now we will move to file and click on save to save this file. So bitwise.c I am giving the program name. Click on the save button. Now go to compile, just click on this button to compile this program. See here compilation done, there is no errors and there is no warnings in this program. Done. Now I am going to run this program. So run this program. So we got this output. Enter a comma b values, the same as I explained, the 10 and 11 I will give here. A value is 10, a value is 10 and b value is 11, because in the previous example I explained manually. The same result we are getting or not, just let me check. See, in bitwise and as we got like 1010 10, in bitwise or 1011 means 11, right? Bitwise exclusive OR, we got one only matched. Bitwise not, see a value is 10, so that's what the 10 opposite line consisted of minus 11 from the logical circle. Now bitwise left shift, see we did previously that 40 we got, and the left shift right shift also we got 2, right? Like this we perform this program. Okay, so this is the best example to understand all this. So now we will go to the next one, special operators. This is the last type operator in the C language, because till now 7 types are completed. This is the 8th type, special operators. By this topic, operators topic completes. Okay, special operators, what are they? Actually C supports the following special type operators. Let me explain that. Size of operator. What do you mean by size? Size is nothing but the size of the data type which we declared. Okay, so as mentioned that the size of operator is used to find the size of any variable. It always returns the value in bytes, because size represents in bytes. So let me take one example. Here integer a equals to 5, and now I want to find that size of a. Actually, what is the value of a? 5. What is the size of a? A is nothing but a variable. Which type of variable? See here, which type of variable? It is a integer type variable. Okay, so due to integer variable, the integer size is nothing but 2 bytes. So that's what, whenever we want to take output, the a value is 5, right? Next, n value is 2, because a value 5 only, but n holds size of a. Okay, here in this example, the size of a is nothing but the size of integer that's stored into the n value. That's stored into the n value. So whenever we take an output of n value, we will get 2 only. So like this, we use size of operator whenever you want to find the size of any variable. It returns in the form of bytes. Next, second one is comma operator. Especially comma is taken as a separator. It is also called as separator operator. Okay, comma operator is used to separate variables and multiple operations. Whenever you are performing multiple operations, it will do just separation. Or whenever you are passing parameters in the function also, we make them to separate by using the comma operator. Okay, so let's we take one example here. Integer b is equals to, integer b is equals to, in this bracket 2 expressions are there. See, 2 operations. We are doing one assignment, a assignment by 3, and here in this operation we are performing addition, that is a plus 2. Okay, so before the comma it operates, means first a value it assigns by 3, and that 3 value is coming to participate after the comma operation. So 3 plus 2, the 5 will be assigned to b. Okay, like this, if you want to take output of a value we will get 3 and b value we will get 5, because that complete value assigned to b. Okay, and the next one is indirection operator. Indirection operator means here asterisk and ampersand both are considered as an indirection operator, as we know that ampersand is used to represent the address of variable. In scanf we are already using to represent the address of variable, and asterisk is used to represent the pointer variables, especially for the pointer variable representation. Okay, so this we will see in the next sessions. And next one is dot operator. A dot operator especially used to access the members of structures and unions. Okay, so this dot operator also we will see in the next sessions whenever we are discussing structures and unions. Okay, so this is the main overview of all the operators. By this video, all 8 operators completed. So we will go to next topic in the next one.